It's time to put in a set of
The reason we exist is because you cannot stay ahead of all threats. So what we do is we block by default.
Hey, what's going on? You're here with E-Tech Millie, and what we got going on is we are on Engines and Brakes ASE training, week 1, day 2, session 2. All right, so we already kind of went over a few videos where we were watching and learning about cam bearings, the cam bearings, the main bearings, the piston slap, the difference of a rod knock and a piston slap. That's something we went over, and we are now going to look into more of the wrist pin, the rear main, the valves, as far as the different kind of valve failures there are, and more about the machine cylinder head jobs and process of doing. Okay, so before we get more into those videos, we're going to go into the science of cylinder heads. And so by doing so, I have attached a few of the articles that we have that we are going to be going over in the description. So if you are looking for this one this time, if you are looking for any of the material, you can find it in the description. All right, so let's go ahead and get into a little bit of it. All right, so cylinder heads. So Force 5.0 liter. Let's first tell you what this is. Static Summit Racing literature. So this is Summit Racing literature that we're going over. So cylinder heads, Ford's 5.0 liter TIVCT Coyote employs a revolutionary new cylinder head design that makes the latest member of the modular engine less bulky while providing extraordinary breathing. The Coyote's intake ports utilize true drive-through service because they outflow even some of the most legendary race heads in history, including the ASE D3 casting for the small block Ford. Perhaps this is an unfair comparison when you consider a two valve versus a 4 valve, but airflow is airflow and power is power. What counts is what you get at the crank and rear wheels. So this is talking about the Coyote, and after that, you see, is that 2 camshafts or is that just one? After that, little bore holes there. All right. The Coyote 4-valve cylinder head is one of the most advanced productions Ford cylinder heads ever produced. Coyote intake ports flow approximately 285 to 290 CFM stock, varying from casting to casting. With CNC porting, you can gain as much as 25 to 40 CFM intake and 20 to 30 CFM exhaust. When the Coyote was introduced in 2011, the media said that these heads actually outflow the ASE D3 small block casting, which is a race head. All right, let's go ahead and look more into it. If you want to read this whole article, again, this whole article is in the description. I just know, like, when it comes down to it, one head is not going to teach us about all the heads, and we're really here more for the diagrams and about the standard cylinder head. All right, so looking at this image right to the top left, Coyote's cylinder heads are left driver and right passenger specific, easily identified by L and R in addition to respective casting numbers. So the L is for driver, the R is for passenger or left, right. Well, kind of. Yeah. Let's go ahead and make it full screen. And blow this up a little bit more so we get more of what you can see more. All right, so they're saying that there's going to be a mark that says L and R, where if you notice, the L is for the driver and the R is for the passenger. If you notice, it's on the dead of the block. So all right, so and respective casting numbers that should be right up under it. You see the numbers. All right, this is the left hand 2015 cylinder head as indicated by the L. Visible here are intake and exhaust cam sensor ports in bolt holes, the arrows. All right, each sensor is cam specific to prevent installation errors. All right, so that was that image there. That was the left, and now we're going to look at the one that says the right. So this is the right-handed this is the right-hand passenger cylinder head on a 2015 Coyote, as indicated by the R. As with the left-hand driver cylinder head, there are intake and exhaust cam sensor ports. So if you notice, they really dang near look like twinsies a little bit. You notice, yeah, they look like twinsies. If not, they are twins. All right, let's move on. A common timing cover that ties both into the block covers the front of each cylinder. It also includes a provision for a timing chain tensioner, which is the orange arrow, which is an oil galley port to provide chain tensioner pressure. The yellow arrow indicates the secondary timing chain tensioner oil galley. All right, now we're to the one to the right. A closer look at the Coyote cylinder head demonstrates the petite nature of this redesigned modular head with this smaller valve train. It reminds me of a motorcycle valve train because it is so small. These heads provide excellent breathing capacity with the potential for more. Spark plugs are centered in the chamber amid for intake and exhaust valves. So yeah, so that's where the spark plugs go. All right. Another angle shows the tighter valve angle of the Coyote cylinder head, which was exactly what Ford engineers were going for to conceive a more compact cylinder head. So yeah, this is another view of it. So let's go ahead and continue on. Let's talk about a few of the facts. So casting produced from 316 grade cast aluminum. Yeah, most of them are made of aluminum and something else. Left and right hand specific heads. 6,049 right, 6,050 left. 2011, 2014 head is most common. Then it's going into particulars of this Coyote. Now again, we're looking for the kind of the standard of the vehicles. So us going through and looking at the specifics for this Coyote is not really going to help us tremendously, so we're not going to go over it. But what we're going to do is we're going to go over the diagrams that really look like all or the majority of the other engines, like this right here. You can tell like this is one of the exhaust portions of the intake or the exhaust. And after that, you see up top, you see where you can input these spark plugs, or 4 of them. So because it's 4 sparks there, okay, all right. So this is the revised 2015 Coyote cylinder head with revised high flow intake ports, stiffer valve springs, larger intake and exhaust valves, and a wider intake port flange for the CMCV induction system. This image right here, the revised 2015 head from the exhaust port side. If you have the budget, the 2015-2016 cylinder head is the better of the 2 Coyote head choices. Just remember that the 2015 head is different from 2011 to 2014 head, which means you must use the 2015 head gasket with its larger unrestricted oil passage for VCT operation. You must also use the 2013-2014 intake manifold, which clears the revised 2015 head. The 2011 to 2012 intake manifold does not fit. So yeah, just because it's saying like, hey, yeah, all right, let you know the previous years doesn't fit. So looking at more of these cylinder heads. So to the left image, the Coyote's generous exhaust ports provide exceptional scavenging compared to the modular 4.6 liter, 5.4 liter siblings. Exhaust valve size for 2015-2016 grew from 31 millimeters slash 1.24 inches to 31.7 millimeters or 1.248 inches. So it grew just a little bit. And after that, this image to the right, here's the revised 2015 to 2016 57cc chamber with larger 37.7 millimeters. So it's 1.485 inches intake valve and 31.7 millimeters. Then it's 1.248 inches exhaust valves. This is the ASE factory chamber, which has not been CNC machined. It has been machined. Okay. So looking at these arrows, the revised 2015 head has these extended intake port flanges which accommodate the CMCV system. This creates interference issues with the 2011 through 2012 intake manifold because of its extensive ribbing. The image to the left. The 2011-2014 head has a shorter intake port flange. This is also a CNC machined intake port. The stock port is rough cast. All right, now we're to the one to the right. A CNC machined Coyote exhaust port yields vastly improved flow over the rough cast stalker. You have a number of options when it comes to CNC port work, including total engine airflow, JPC racing, and Slocco racing. Okay, there we go with the little gaskets, the little head gaskets. All right, and those are a couple little pins. Guess what they say, the heads. Yeah. This is performance racing parts head swap kit, the M6067-M50, which includes these high-tech composition gaskets and fastening head hardware, Plan on fresh gaskets and bolts whenever you swap heads. This is the 2015-2016 head gasket with enlarged VCV provision. Arrow, well, that's where the arrow is right here. And okay, thank you for it. All right. So we have more images of course, again, if you really want to check this whole thing out, you can. I mean, it's great information. And right now, I mean, you see little for the ports for the exhaust or the intake. Right here, you see where the sparks is. Then you see a lot of the valves. Yeah. Those are springs. Not sure, but so here's the chamber side. There it goes. See those? All I can think of like is the beat of a lion. You know, that's all I can see when I see this. So this is the head studs for the Coyote. Here's the gaskets. Okay, so let's go ahead and get back to it. Yeah, so we went over a little bit of just how the Coyote look. I really don't want to go too deep into the Coyote because it's not about one particular cylinder head, head gasket cover and all that. It's not too much of one particular one we're looking at. We're looking at really all of them. And as you notice, something with the LNR and then having the specifications right around there, that's something that is pretty standard practice. So that's something that we can say where it's not any one particular, but at the same time, let's go ahead and all right, let's go ahead and continue on. Give me 2 seconds. Yes, but if you really want to know more about like the racing science behind engine like the Coyote, I really highly recommend you check out the article by Summit Racing. I really do appreciate the knowledge that they provide. Going into a summit is a beautiful experience for somebody who really wants to explore just the power of the engines. But yeah, let's go ahead and move on. So now let's focus on this right here. So introducing internal combustion engines. Get started with your lesson. The questions to ask, we need to ask is, what's the difference between a motor and an engine? What is a motor or an engine? Why do we put gasoline in the car? How would you like an exact scientific definition of motor and engine? Those are the questions to ask. So what is a motor? Motor comes from the Latin word to move. It pretty easy to understand where we got that term, right? Today we refer to a motor as a device which is powered by one form of energy and converts it to motion. So move, motor. I see how we got there. All right. 1 sec. All right. I'm gonna move on and do it in good faith. For the most part. All right. So let's go ahead and talk about what a engine is. So the motor, again, it was first used from Latin move, and then motor. I guess that's the best way to put it. And then after that, we talk about powered by one form of energy and converts it to motion. So remember the conversion of energy from light in energy unit study. So what is an engine? Engine comes from the same word as ingenious or ingenuity. In antiquity, the term was applied to engines of war or catapults. In the Middle Ages, they developed entire engines of torture, not too ingenious, huh? So today we refer to an engine as a motor that burns fuel in order to produce mobility or kinetic energy. So engine and motor seems like similar, very similar. So gasoline and engines. So what do we use the gasoline for? We burn it in an engine which converts the heat energy into kinetic energy. What is an internal combustion engine? Cars and trucks use internal combustion engines. You probably can figure out what this means. Internal, inside the car. Combustion, burning fuel in the presence of oxygen. Engine, converts heat energy into motion. Then we talk about the combustion of gasoline. So what would happen if you light a match and threw it in a barrel of gasoline? Kaboom. Not only would you get killed, you would also cause an explosion that could take down a block of houses. Very bad idea. Butane. But instead of gas, butane. You can burn butane from a butane lighter. When you strike it open, a small spark lights that butane, which then burns in the presence of oxygen. You can see a little chemical code right there for propane. If you have a propane grill, the same thing happens. You need the propane fuel, the oxygen in the spark to cause the fuel to burn. Then you have gasoline, and then from gasoline, and while we don't want you to burn gasoline, here's the chemical equation. So, all right. Floor combustion, a little combustion demo that's dangerous. Let's not. Well, I mean, I guess if you really want to do that, you can do that. But this is basically adult supervised. One, you can work with your kid. So using a stove, a knife, a scissors. If this is something that you'll like to do, go ahead and work it with your kid. I'm not going to work with it. So, but if you like to, go ahead and work it with your kid or whoever you would like to. But as far as combustion in your car, we're going to go over the 4 stages. All right. So the 4 stages of internal combustion. So now let's look at how the combustion reactions make your car run. We are going to look at the answer key to match card. You see 4 different diagrams of an engine as it goes through the 4 phases of the combustion cycle. The circle at the bottom is the crankshaft. As it spins, it moves the pistons up and down in the tube. Look at the 4 picks and notice how the pistons go up and down. That's the entire job. So, okay, so it's not showing us that, but at the same time, I do have the card where it's showing us right here. This is the entire sequence. It's a 4-stroke where you're going to go through the intake, the combustion stroke, as well as the compression and exhaust stroke. So when we're looking at this, we know that the intake stroke, the piston is moving downward. That allows the gasoline and air to move into the engine as the arrow shows. It's the same principle as inhalation. When you inhale, the diaphragm moves downward and air moves in to fill the empty space. But this is more than just air. It is air in fuel, gasoline. What did our little flower demonstration show us? And then it's supposed to show us combustion requires oxygen molecules surrounding the fuel. And then this is where we're at right here, where this is the intake stroke right here, going down, downward motion. And then it even tells you right here where it gives you more explanations. So this is a good card to use. Compression stroke. Look what happens when the crankshaft turns, the piston moves up. The valve at the top are closed off and the air and fuel are pressed together. Makes sense. They call it compression stroke. So looking at this compression is going back up and it's compressing. So it's going back and it's tightening up again. And here's a spark plug right here. All right, here's a spark plug. Boom. Air goes in, oxygen, air. The fuel goes in. It goes intakes and it comes back up. It compresses, gets tight, and then this is where it actually ignites. All right, so the combustion stroke. Here comes the fun. See the spark plug at the top of the engine casing. Guess what it does? Yep, it sparks just like the spark on a butane lighter and all the compressed fuel and oxygen. You got it. A little boom that pushes the piston downward. So that's what that boom is. So again, it goes up, compresses, and comes down, and then it boom. All right. So that's what that is there. Exhaust stroke. Not stopping just because a little explosion happened. The engine keeps working and the piston is coming back up. The exhaust valve opens and the waste products of the combustion reaction leaves the engine. On your car, the exhaust will eventually exit from the exhaust pipes. So yeah, so that's what this is, where it basically comes back down and then it pushes out that last bang. So that smoke and all that stuff, it gets kicked out. And remember, you have a multiple amount of spark plugs. Normally you at least have 4. So a lot of cases, if you have 4 spark plugs, you got 4 of these things stroking. 6 of them, 6 of them, 8 of them, 8 of them. All right. So it's easier to get the animation less than 3 minutes. And after that, let's go ahead and okay, this is no longer available. Well, it's okay. Well, right now, what we've done, I feel that we have gone over a lot of the cylinder head science of. The only thing we didn't focus in on was the valve failures, which I believe. Yeah. So we have a few of these in the future videos. So I'm not going to harp on us not looking at them now. At the same time, what we're going to be doing, we're going to be focused on getting our training from, again, the things that I don't know that I'm learning. I look at it, I write it down, and then I create a playlist of those items for all of us to go through. Or I know some stuff that is very important to others. I put that in there. So let's go ahead and continue on.
Hey guys, welcome back to our repair guys. Thank you guys for watching and subscribing. In today's video guys, we're going to explain what piston slap sounds like, how to know if it's a piston slap, okay, and we'll also have the video fixing that I wanted with a piston slap guys. Quite a few videos coming if you have one of those vehicles. We also have BMWs, Fords, all kind of stuff on the channel, so please subscribe. Also please give a subscribe to our new channel, Electrical Car Repair Live. Quite a few videos will come there as well. So Hyundai Elantras guys, that generation from 2011 to 2016, they're prone to engine knocks. Even with low miles, I read some people will do that with 20,000 miles on the vehicle. Ours has 69 as of right now. He has a piston slap, and we will explain, okay, what we did and how to know that it's a piston slap. So first thing guys, we changed the oil, right? You think that it might be oil, so you're hoping that it will go away. After that, it read that you have to use original oil filter. So after that, we purchased original filter from Hyundai, oil filter, installed it, put new oil, still the same thing. Okay, now, the thing about it is when the car idles, you do not hear it as much. Listen now, listen now. You can hear a little bit of tick, 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 but not much. Piston slap, usually guys, you can hear it when the car is under load. When you give it gas, like climbing, especially a hill, or give it gas, you'll feel it. Okay, so let's give it gas now. And when you let off the gas, it will go away. Okay, let's go again, gas. Okay guys, that's a piston slap right there. How you can also diagnose those? Usually, okay, you can, what we've done, we remove the engine cover and we disconnect the injectors for the certain cylinders. That way, eventually the piston slap, let's say piston number 2, has a slap, has a play. When you remove the connection from injector number 2, you will not have fuel inside the piston, so it will not have as much compression, and you will not be able to hear the knock so much. So that's the way to figure out. Also guys, if you start climbing a hill, okay, you give it gas, you'll be able to hear that knock even more. That's most likely piston slap or rod bearing. Rod bearing, it could be a crank bearing as well, but it's really hard to diagnose. But piston slap, you'll be able to hear it more in the top end of the engine, more like the head. It will sound a little bit kind of like having a bad valve or a bad lifter. And on the other side, if you have a bad rod bearing, you'll be able to hear the knock on the bottom of the engine more. In our case, we definitely hear it like about right here. You can hear the knock, so it sounds like it's a valve or a lifter, but it's not. We have the video taking things apart, getting to the piston, and we'll explain more of the piston slap once we remove it. So please subscribe, many more videos to come guys, and see you next time.
Gudgeon pin. A gudgeon pin, also known as a wrist pin, is a small metal pin that connects a piston to a connecting rod in an internal combustion engine. It plays a crucial role in the engine's operation. Functions: 1. Piston connection, links the piston to the connecting rod. 2. Motion transfer, transfers the up and down motion of the piston to the connecting rod. 3. Supports piston, helps maintain the piston's position and alignment. Location: piston end, located at the top of the connecting rod, inside the piston. The piston pin is fitted on this part of the piston to connect the piston and the connecting rod. In some cases, it is reinforced with ribs so that it can withstand the combustion pressure. When the engine is being operated in a clockwise direction, when viewing the engine from the front, the left side of the engine is the maximum thrust side and the right side is the minimum thrust side.
Hi there, I'm Wake Speed Jr. I'm Keith Jones. We're both a Total Seal. And today we want to talk to you about the difference between a wrist pin and a piston ring. Now, you may be wondering, well, one's a pin and one's a ring. But this is where it gets interesting. Keith, my humble opinion, one of these is a structural component of the piston, and one of them is a piston ring.
I agree with that 100%.
So we all know that the pin is actually the backbone of the piston. This thing's going up and down. It's made out of aluminum. There's all kinds of stresses and strains on that piston. That pin is holding all that together. It's the backbone of the piston.
It's your structural support. It's the foundation.
There you go. I got the foundation.
Without that pin, guess what? All this is folding, moving, bending, pinching,
Right.
clamping.
You need this to be a strong part.
Absolutely.
We've got some common friends from the pro stock arena that have seen what happens when you make this too light and too thin. If it starts to go oval and not round, bad things happen.
You've got problems. House is only as good as the foundation. Just a quick story.
Mm-hmm.
Customer doing big diesel pullers, big power,
Oh, yeah.
250
That's
pounds
the cylinder
of
pressure there,
Oh
yeah.
boy, is it. All of a sudden, he's having ring problems. And we kept digging and digging and digging, and what we come to find out is they used the same length pin on one bore size, and then we made the big, I shouldn't say we, he made the bore size a lot bigger, kept using that same pin.
Ooh.
Guess what? A whole lot of piston with no support in it.
Right, more area to move.
And it was binding the rings up in the grooves.
Got it. Right, just that's a structural support. And it's a great segue to the fact that the piston ring is a seal. It is not the structural component. Even if that piston's moving, no matter what thickness of the ring, bad things are going to happen.
Bad things are going to happen.
Like I said, binds in the groove, what happens?
Ring seal's out the door, and if you think about it like this, if that ring stops doing its job, what happens? Hot combustion gases, fluids, flame, all go down the side of that cylinder. You think about something, it lost the ring. Well, in the big picture, okay, it lost the ring. But why? Black Death the skirt. Lock the piston up, rip that wrist pin out of the piston, and shot her out through the side of the block. All because it's a simple thing. I lost ring seal.
Okay, so this is not a structural component of the piston, which means you don't have to be afraid of going to a thinner ring and it hurting the piston.
It's not going to hurt it anyway. If anything, that thinner ring is going to have better bore conformability. It's going to follow that cylinder better. It's an odd thing, doing what we do all day, and as long as we've done it. There was that day where, the 5/64 ring, and then you had that skinny 16th inch ring. Man,
Right.
I'm not sure about that 16th. Then it was, man, that old
43. Oh, that's high-end racing stuff now. Rebuild it every race.
can't put that in there. That will never hold up.
But the reality is, there are rings now that are half the thickness of an 043 that run, at least 3 or 4, 5 times the life of what that 043 ring did in a race application.
In full race, and go back to the production. There are production engines today that you're going to expect to get 200,000+ miles out of that have thinner rings than 043 stock.
From the factory.
From the factory, with a warranty.
Exactly. So I hope you get this idea of there is a difference between a piston ring and a wrist pin. One of them's structural, one of them's not. This one you want it to be strong and heavy and all that. Those are good properties
Yes, you want it
of
to-
this.
yep.
This is a seal. You don't need to be stuck on it being thick, heavy, big. No. You know what? You wouldn't put a cast iron gasket between your cylinder head and block and think it's going to seal very well.
Not for long.
Right? You want it to be flexible and pliable. Piston ring needs to be more like that gasket than it does a cylinder head.
It's got to be able to move and conform and bend, move heat out of everything,
Right.
keep that piston cool. That thinner, lighter ring is going to survive that environment. Don't be afraid of it. It is the modern way.
Right? Have you even seen thinner rings make less engine temperature because it reduces friction?
Lower friction.
Piston ring, thinner, lighter, better. wrist pin, thicker, stronger, better. Hope you enjoyed the video. Thanks for watching.
Chevy Vortec one-piece rear main seal. Place your screwdriver in this notch and give it some light taps with a hammer until it digs into the seal a bit. Be sure to aim towards the seal and not towards the... Pry out one notch at a... Clean. Carefully start by use the seal and hammer to drive.
Leaks in oil are often among the most difficult mechanical problems to identify. Leaks in oil are
Chevy Vortec one-piece rear main seal. Place your screwdriver in this notch and give it some light taps with a hammer until it digs into the seal a bit. Be sure to aim towards the seal and not towards the... Pry out one notch at a... Clean. Carefully start by use the seal and hammer to drive.
Leaks in oil are often among the most difficult mechanical problems to identify and repair.
All right, so I really appreciate y'all staying by, learning, and trying to absorb whatever you can. If you're taking the ASE engines in the brake one, we are now going to do the rest of the brake exam, and then after that, we're gonna have to see if we get what we got and go from there. All right. So what we have, 15, technician A says a defective wheel or axle bearing can make a growling or rumbling noise. Technician B says a defective wheel display looseness or excessive play in the steering wheel, especially while driving over rough road surfaces. Who is right? So A says defective wheel or axle bearing can make a growling or rumbling noise. I guess. And then says defective wheel display looseness or excessive play in steering wheel, especially while driving over rough surfaces. Yeah, both of them are right. All right, so the front wheel bearings are being adjusted. Technician A says you torque the adjusting nut to a specified torque and back off the nut until it lines up with the hole and install the cutter pin. Technician B says backing off the castle nut will cause the bearing to overheat. Who is right? Yeah, let's go with B. All right. Disc brake DNR. This question has the word accept. Read the question carefully before choosing your answer. All of these would cause a low brake pedal, brake adjustment, loose wheel bearing, low brake fluid. Yeah. C's caliber piston. Brake adjustment, loose wheel bearings. We're going to go with C's caliber piston. All right, a spongy brake pedal on a vehicle with four-wheel disc brakes with a longer than normal travel indicates which of the following? A spongy brake pedal on a vehicle with four-wheel disc brakes with a longer than normal travel indicates air in the hydraulic system, caliber piston C's, parking brake out of adjustment, a faulty power booster. All right, I'm gonna say it might be air in the in the brakes. That's what I'm gonna say. A vehicle with four-wheel disc brakes has a brake squeal. Technician A says a defective proportional valve could be the cause. Technician B says disc brake squeal is often caused by movement of the disc brake pad during braking. I'm gonna go with both of them. On a car with single piston floating caliber disc brakes, the disc brake pad between the caliber piston and the rotor is badly worn. The other brake pad is slightly worn. Technician A says excessive rotor run out could be the cause. Technician B says insufficient clearance between the pads could between the pads and caliber slider could be the cause. I'm gonna go with both again. The ABS anti-lock brake system and traction off indicator light remain on with the engine running. Okay, the ABS and the traction off when the engine running. All right. Technician A says the check for ABS or TCS diagnose trouble codes. Technician B says you can check for the ABS blink codes on older vehicles by connecting 2 pins to the data link connector. Okay, we're going to go with both again. A wheel speed sensor is being diagnosed using the OEM, the original equipment manufacturer diagnostic scan tool. Technician A says to verify wheel speed sensor operation, compare all 4 wheel speed sensor outputs to vehicle speed on the data list. Technician B says the wheel's direction of rotation can verify by looking at the wheel direction on the scan tool data list. Who is right? I'm gonna go with both again. I do not like these he say she say stuff, but at the same time, what do you think? The front brake rotors and pads are being replaced on a vehicle equipped with a TCS traction control system and electronic stability control system ESC. Technician A says the yaw rate deceleration sensor should be recalibrated. Technician B says the new rotors should be indexed to the hub using a dial indicator for the least amount of run out. We're gonna go with B. The ABS amber light does not go off after the engine started. Technician A says a parking brake not fully released could be the cause. That's true. Technician B says when this happens, the brake will operate like a normal non-ABS. Let's go with both. See what we got. Okay, not horrible. We didn't pass. We barely failed, you know. You know, we failed a little bit. It's okay. Yeah, so 50% on the hydraulic system, DNR. Drum brakes, 38%. Drum disc diagnose, DNR, 50%. Then electronic brake control system, 75%. So, okay. This lets us know what we need to focus on. It's kind of like how we started focus on the cylinder head. You figure out where you're weak at, and then you work on it. So, yeah, let me see. I'll put that pin. Okay, so I guess yeah, I misplaced the pen. Oh, there go the pen. All right. So now we got this pen. Let's go ahead and figure out which ones we need to work on the most. So out of this, we have the hydraulic, system, and we're gonna go DNR. Then we have drum brake. Then we have disc brake. And then we have the electronic, the ESC, ABCNTCS, all those 3 letters. All right. And then what we got? We have out of the hydraulic, we have 50%, 0.5. Out of the drum brake, we had 0.38, almost 48%, almost 40%. The drum brake, we had 50%. And then for the 3 letters, we had 75%. So when it comes to that, we're not bad. But all in all, we were 50. I was 50%. Meaning that if I was to take this test tomorrow, I'll probably fail, which is okay. So what we're going to be doing is we're going to be going over these mistakes, and I'm just going to scroll over them and giving it a few moments for people to be able to screenshot or whatever you want to do. I will be coming back to this and working on more of it in a little bit as far as, you know, what I got wrong on it. But if you would like to kind of look and see what you got right or wrong, this is the time to kind of look. I'm just slowly going up. Again, this test could be found on test.com. And then there are plenty of practice exams. They have a practice exam from every ASE automotive test. They have all of those exams. Yeah, I need to work on that he say, she say stuff. Or all right. Okay, so if you got a bunch of them right, that's good. Remember, in order to pass this one, it has to be 22 out of 40. So in a sense, it's like 55%. So looking at that, I kind of failed, but it's okay. I barely failed. I failed by 5%. So again, I plan on taking this exam at the end of the month, or after I feel like, okay, I'm ready to take it. One of the two, whichever one comes first. So yeah, so I highly recommend, if you want to learn more about the intake and just the combustion, intake, compression, combustion, and then also the exhaust strokes, I highly recommend figuring this out and just knowing how to use this. I guess this right here is something that would be great. A match card. Again, this right here is going to be in the description. Well, actually, it is in the description. So if you would like to check that out, you can check that out. And I believe we are done. And let's go ahead and we're gonna bounce out. All right, let's do it.